So, my name is Alexander Birikov, and this is an introduction to DevOps. So, DevOps obviously stands for Development plus Operations. So, this is a little bit about myself. I've been working in the software development industry since 2013 for several companies, and I've been using DevOps tools and practices, CI/CD, and different clouds extensively throughout my career. So if you want to contact me, please feel free to reach out to me on LinkedIn or Telegram. And for training, you can you hear me? So sorry. Okay, just your voice it became so. Please also for training, feel free to book me on coding bootcamps. So this is the agenda. So what's DevOps actually? So during software development, usually there are different teams, development teams, which develops the source code, using programming languages, and targeting in different platforms with different frameworks. And there's operations team which supports the already developed product. Their main focus is to monitor the state of the application, as well as just supporting its environment, like operating system behind the application, and also networking and communications between servers and stuff like that. And these teams previously were often separated, not only physically, but always in time, because development usually precedes, used to precede the support phase, and there was not too much communication between these teams. But with the adoption of clouds and with more rapid software development cycles, like agile methodologies, and this separation became not so convenient for everyone, because the software development and support phases became they run simultaneously in short phases right now. So the iterations are shorter than they used to be before. And that's why new methodologies and the very term of DevOps appeared. So this you can you can see the definition of DevOps here. So it includes different practices as well as different tools. DevOps is usually associated with a set of tools like automation scripts, monitoring, building, and testing. So and CI/CD stands for continuous integration, continuous delivery, which means that the software that was built is delivered in all the time, like with short patches to production. And there's no separate phases like in the previous waterfall scheme. And so all this communication and integration of development and operations provides better trust between teams and eliminates bugs and allows to iterate quicker for everyone. So this is a better illustration how the process works. And so it all starts with planning, where the feature is planned usually using drawing tools like block schemas, like draw.io, for example, and then the developers who see the plan start working on developing features like using programming languages, and also they use version control systems like Git. Currently the most popular version control system is Git, but previously there were many, including centralized like Subversion, for example, and decentralized like Mercurial and others. And after the code is developed, and usually it goes to testers, to the quality assurance team, where it's verified against predefined use cases. And for that, usually different testing frameworks are used, like Selenium, for example, for integration testing of web pages. Selenium WebDriver allows you to go over the web page, simulating user clicks and page navigation and stuff like that. And after after it's verified, the quality is proved, and the application is good to go to this production service. That's where packaging happens. And for packaging, there are special tools that allows to compose different software components. They depend on the programming language. For example, in the Java world, it's usually a Maven or Gradle. And in JavaScript, it's Webpack and NPM. And in .NET, it can be Nougat, for example. And after these artifacts are created, they are propagated further to the production servers. And currently Microservices architecture is the most popular one for running software applications. And for these microservices, it's best to use abstractions above the underlying operating system. And because operating systems are too low level and they have different behaviors that's hard to control. That's why more abstracted sandboxed environment are created, which have more predictable behavior. First, they were virtual machines, and then after that, above virtual machines, even better, more isolated sandboxes were created, like Docker containers, for example. And for orchestrating this Docker containers, because Docker container is basically corresponds to one application, one microservice, and for the whole application that includes several microservices, there should be an orchestrating system, and the most popular one is Kubernetes. So Docker and Kubernetes utilize configuration files, like Docker files, for example. They include basically Unix commands similar to Bash shell scripts, and Kubernetes uses YAML files for declaring the desired behavior, the desired resources that are required for the application to run. For example, the number of CPU cores and the amount of memory required to run each instance of the service. And so these configuration files are more declarative than procedural, because the platform knows how to recreate the environment using this declarative language. And after the artifacts are deployed, and there should be some kind of monitoring and to prevent failures and recover from them. So for this, also in Kubernetes, there are plugins that allow you to monitor the state of the cluster, and Kubernetes pods are automatically recreated if they fail for some reason. And after this release cycle is finished for the first time, it's actually a very short cycle, usually just one sprint in terms of a Scrum for methodology. So it's like 2 weeks usually. And after that, the next cycle happens with planning, creating, verifying, packaging, and so on, repeating all these stages all over again. So each team, development and operations team, work simultaneously. And they use these configuration files to communicate with each other, because developers can actually write these Docker files and even Kubernetes configurations like Helm charts, for example, that have several YAML files packaged together. And also the developers can understand the desired state of the production network and production service. They can estimate the resources that are needed to run their applications, so that they can help the operations team writing in advance these configuration files. So other tools used in DevOps are Ansible. Ansible is more imperative. It's not as declarative as Docker and Kubernetes, and it works similar to Bash. It's especially effective in use cases where it's impossible to define the whole system state like in advance. If you need provide more details about the process of deployment, or for example, if you need authorization or authentication to some external systems, it's good to write the script and providing all the steps details using some kind of macros above Bash scripts. So this is basically what Ansible does. And there also, I already talked about Docker Kubernetes, so other tools are Chef. It's also working with configurations called recipes, and it basically describes the desired state and behavior of the servers. And Puppet is also a pretty old tool that helps in configuration and orchestration of the production service. And more recent, another more recent tool is Terraform, and it's more declarative, unlike Ansible, which is imperative. Terraform is more declarative, and it works best with more predictable environments like Kubernetes clusters, for example. And you can describe all the steps using Terraform configs, and including your CI/CD steps, like building your application from Git repository in GitLab, for example. And then you can describe the Helm charts that describe the production and servers, like web servers, for example, Nginx configuration for reverse proxy, for example. And so all these steps, all the software development and delivering steps can be pre-configured using Terraform, so that you will not need to execute the steps manually. You can just write these configuration files all in advance, and the whole process will be managed and run automatically once you push your changes to this source code repository, like Git. So, and what's next? Jenkins is another CI/CD environment. So this diagram shows where they all belong. Jenkins is similar to Bamboo or GitLab CI/CD. It has agents, which are dedicated programs that execute building your source codes from the source code repository, from Git or Subversion, for example. And so they actually do this building. They tell Maven or Gradle to build your source code, and then they can proceed to the next steps and execute tests on top of the pre-built artifacts. So they can verify the system that was built using these testing tools like JUnit or Selenium, for example. And after the artifacts are verified against the written test cases, they can be deployed to the production environment. And in order to do that, they use Docker files, for example, where the required steps for building are described. And after that, after the artifacts are deployed to this production service, they can be managed using these tools like Puppet and Chef to monitor this its state in production, and to integrate with external tools and services. And yeah, so this is for integration, and for monitoring there are actually more tools like this Nagios and Splunk. So DevOps is a very popular tool, and it's obviously used by pretty much every big company and even small companies right now, and it's growing in popularity. There's basically no alternative way. It's a very common approach because it allows you to iterate between cycles faster than without it. So I already talked about CI/CD, so I don't think I'll need to pay attention to that slide. So this is the whole flow, and basically the developer writes code. They then commit, which means they save the code in a source control system, and can also attach some external code from other repositories. And after that, as I already talked about it in the Maven Gradle section, so it's all built, goes through testing, first unit, which is more fine-grained, and then integration, which covers the whole system together with other services compared to unit, which tests in isolation. And so this is basically the development side, and after that the code and the code is built, and the artifacts like Docker images are propagated further to the delivery pipeline. So, and this Jenkins tool helps you automate all this process. It has agents, as I described previously, that fetch your code from the source code repository and proceeds through all these steps all the way to the production servers. And we'll actually cover Docker and Kubernetes more in detail in future webinars, because these tools are essential, unlike Jenkins, which can be replaced with other similar tools like TeamCity or Bamboo or GitLab CI/CD tools. Docker and Kubernetes are basically industry standards, and there are no popular alternative to Docker containers and Kubernetes container orchestration. So if you have any questions, please feel free.